Let's now talk about biological immortality.
Mm.
There's no law of physics which says that you cannot live forever. And so the question is, why can't we live forever? Well, the second law of thermodynamics says that in a closed system, you eventually die. You age, you fall apart, errors build up, and you eventually die. That's the second law of thermodynamics for a closed system, law of physics. But there's a loophole in the laws of thermodynamics. In a closed system, like a box, you will eventually die. Errors build up, things rust, things fall apart, things decay. That's a law of physics, okay? But notice I said closed. If it was opened, if you opened the box and energy can come in from the outside, then in principle you could live forever. Because what is aging? Aging is the buildup of air. That's all aging is. The buildup of air. Air in our DNA, errors in protein synthesis, errors at the atomic and molecular level, and that's where quantum computers comes into picture. Because quantum computers live in the quantum world. Immortality is, therefore, possible. Of course, I'm not saying that we can do it now. I'm just saying that in principle, it may be possible. So, for example, if you take a look at a car and you ask, where does the car age? You would say the car ages in the end up. You have oxidation. You have wear and tear. So where is the engine of a cell? Where you have oxidation. That's where you have, quote, moving parts in the buildup of air. So if we could then fix the air buildup in the mitochondria, you would then be able to reverse aging. Computers will be able to isolate the process which makes aging possible. Some animals live forever. Look at the hydra. The hydra is a microscopic animal found in a pond. You try to destroy it, and it regenerates itself. It lives forever. Okay, it's immortal. And so the question is, why can't we do it? And believe it or not, some of the biggest names in Silicon Valley are now beginning to put their money on the table, looking at ways to regenerate cells, looking for ways to reverse the aging process. And one day we may be able to create a certain form of immortality, not digital immortality that we more or less. In other words, aging is a quantum mechanical process. It's the buildup of error. Okay, that's a quantum mechanical process. If the atom were a billiard ball, you couldn't talk about this. This is only possible because atoms are not billiard balls. They're quantum mechanical. They can form bonds. They interact with each other. They create enzymes to speed up processes, so on and so forth. And so one day we will find the key ingredients that make aging possible. Why is it possible to, why do we age? We age because of the buildup of mistakes. Every time a cell divides, every time you're hit with a cosmic ray, every time you take a piece of or a material that's slightly poisonous, you speed up the aging process, the buildup of mistakes. And that's where quantum computers can come in, because they may allow us to repair those mistakes. Cells have repair mechanisms, okay? Otherwise, we would all age immediately, right? We would be able to isolate them, find them, and use them. And that's a process that we are working on right now. And that's why Silicon Valley now is putting billions of dollars to find the fountain of youth. Silicon Valley, they're no fools there. They're investing in quantum computers. Some of the biggest startups in Silicon Valley are all based on quantum computers because they realize this is the future. Yeah, we're still in the experimental stage. We've passed what is called quantum supremacy. Quantum supremacy is the point at which a quantum computer can exceed the power of a digital computer for a certain task. That has already been breached. The Chinese and the scientists in America now have quantum computers that exceed by factors of millions of times more powerful than a digital computer for a certain task. Now, notice a computer that works for all tasks, and we're not there yet. Okay. The main problem is that we have to cool these things down to near absolute zero so that there's no air buildup. If somebody sneezes or somebody jumps up and down, small little vibrations will move the molecules so that the chemical reaction falls apart. So you want it to be totally stationary. You want it to be away from any vibration, and you want to cool it down to near absolute zero. Now, Mother Nature does this at room temperature. Nature is ahead of us. We can't yet do it at room temperature. But that's the goal. The goal is at very cold temperatures, we want to be able to simulate quantum processes.